Hi, this is David Voss, CCIE 11372, and in this video we are going to cover BGP design. The first thing we're going to do is do an overview of BGP, and then we're going to get a little bit more granular and we'll talk about BGP path attributes, BGP AS path, eBGP versus iBGP, public versus private ASNs, BGP updates, and how BGP advertises routes. All this information you will need to know to understand how to properly design BGP and do well on this portion of the CCDA exam. So let's go ahead and begin with an overview of BGP.
BGP is an exterior gateway protocol that uses autonomous system numbers. It uses TCP 179 to communicate between neighbors. And it really is a protocol that requires manual configuration for almost everything. It doesn't really do anything unless you tell it to do it, which I really like about the protocol. Now, it uses path attributes, which are key in decision making on choosing best route. So path attributes define information about a path, but also this information can be used to help decide upon the best path. And we will draw that out in a minute here so you can understand that better. Now, regarding BGP path attributes, there are some that you absolutely have to know and memorize. The first is weight. Weight influences a best route for the local router, and obviously it's manually configured. Local preference influences the best route for all routers in an autonomous system, so this is a shared attribute. AS path lists the number of autonomous system numbers in the path, and this can be manipulated. Origin is a value implying if the route is from an IGP or an EGP. And then finally the MED, which can influence the best route for routers in another AS. So you can influence traffic flows into your AS by sending out the MED to other routers. So here you can see we have two routers that are in autonomous system 700. And then upstream, we have another router in autonomous system 140 and autonomous system 87. So here you see there are 4 hops. But as far as BGP is concerned, it's just counting ASs. So it counts 1, 2, 3 ASs. The AS path is 700, 140, and 87. Why is this important to know? Because here's another flow that has 2 routers in AS700 and then 1 router in AS87. Now, according to this path, there's just 2 ASs. That would be the preferred path. It's critical to understand that BGP is concerned about AS path and not so much about hop count. AS path is a key attribute to understand. Now, internal versus external BGP. iBGP is something you would run basically interior to your company. It's BGP connectivity within the same autonomous system. In this, routers do not update AS path. Normally they should never have to because you're running the same autonomous system. And in iBGP, things should always be meshed. Routers should always be fully meshed. And there are ways you can get around this, and we'll talk about that in a little bit. Now, eBGP is external connectivity to other ASs. And routers do update the AS path in those cases. So let's say we have an autonomous system 200, and in our company we're running iBGP full mesh between all routers. And let's say we have connectivity to 2 upstream providers. One is Autonomous System 301 and the other provider is Autonomous System 450. Now, between ourselves and our providers, we are running eBGP because it's 2 different ASs. And internally, we are running iBGP because we are communicating between the same AS. Now, configuration between iBGP and eBGP is quite similar. The main difference is you're choosing to communicate with the same AS or a different AS. Now let's say we want to communicate to a web server over the internet. And we have a certain amount of hops. Now, let's say one of those paths through AS450 takes us through quite a few more hops, but it takes us through fewer ASs. So let's just say, for example, we go through AS900 and then AS100. So that's 450, 900, and 100. Those are the three ASs we traverse in order to reach that route. Now let's say on this flow through Autonomous System 301, we go through fewer hops but more ASs. Now, even though there's fewer hops, because there are more ASs, we're not going to prefer this route. There are 5 ASs in this path. That is not going to be preferred to the other path, which has only 3 ASs. So we're going to choose that path. We'll choose the 3 AS path. Now let's say we're running a web server inside of our company, and we're running iBGP between these 3 routers, and we're connecting to 2 upstream providers using eBGP. And let's say we have users on the internet who are trying to get to this web server. We can manipulate the AS path attribute in BGP to make them prefer one path over the other. And the way we do that, now let's say our autonomous system is 50, we can manipulate the AS path attribute by adding to the AS path on one of our links. So, for example, the users know that they can reach the web server via one AS. Well, we're going to increase that on the top router, and we're going to manipulate it manually and add our AS over and over again to the AS path attribute. And the users, as far as BGP is concerned, that now is a longer path, and therefore the users will prefer the bottom path because it's only one hop, one AS hop. Now, if that router were to fail, users would then prefer the other path. So you see, you can manipulate traffic flows that way. Now, you need to understand the concept of public and private ASNs, and this shouldn't be foreign to you because you understand public and private IP addressing. So autonomous system numbers are chosen from this pool, and you can use them for private use or public use as need be, but you should be aware of that chart. Now, regarding BGP updates that we receive from neighbors, you can receive from your provider a default route only, which many people do. Or you can receive a full BGP routing table. That is literally every route that's available on the internet. Or you can receive just partial updates. And that is, maybe the provider knows about certain routes via a better path than most other providers. You can just receive a partial update from your provider. So you should know that you can receive those 3 different types of updates. That should be known for your CCNP route exam. Now, regarding advertising routes, advertising BGP routes can be done 4 ways, either through the manual network command, redistribution of BGP into IGP, or propagation of existing BGP routes, or again, manually using the aggregate address command. Maybe the best way to explain these is to simply draw it out. Now imagine we have a router with an iBGP connection and an eBGP connection to an upstream provider. So there's our eBGP connection, here's our iBGP connection, and we're autonomous system, let's say 400. So on a router, we can advertise in 4 different ways. We can manually specify the network we want to advertise by literally typing it in, network 10.10.10.0 or network 198.110, and we can forward that via iBGP and or eBGP. The other way is we can learn routes via BGP and redistribute that route into, let's say, an interior routing protocol. Let's say if we're running OSPF, we can take the routes we learn from our eBGP neighbor and redistribute them. The other way is to simply pass the routes we're learning from our eBGP neighbor via BGP internally to our iBGP neighbor. So that's just forwarding the information on. And finally, we can again manually set an aggregate address on the router, and that's a manual configuration to aggregate some of the routes. And again, that can be advertised out either way. So the rule of synchronization in BGP, you should simply know this, that BGP will not advertise a route unless it knows about that route via an IGP. That's what you really need to know for the exam. Now you can disable this by typing no synchronization on your router, and then it will simply forward routes that are not in the IGP.
So here's what you've learned. You've received an overview of BGP, and we dug in a little bit on BGP path attributes, AS path, eBGP and iBGP, public and private ASNs, BGP updates, and then the advertisement of routes. All of this you will need to know for your CCDA exam, and if you master this material, I'm confident you will do very well on this portion of your CCDA exam. Good luck in your studies.